how do we get from this to the second to the last step? So the antiderivative of u cubed is 1/4 u to the fourth. And then I simply pulled out the 1/2 so that it's this 1/2 that's right here. This 1/2 I pulled out right here. And then u equals 1 and u equals 2 are values that I got when I plugged 0 into here and 1 into here. And then from there, direct substitution, 2 to the fourth is 16. And then 1 to the fourth is 1. And then if you have 1/8 up front, that should give you 16 minus 1 equals 15/8. And again, this part right here where you guys have a constant, you can actually pull the constant out and just do u to the fourth and then 1 to 2. And so that would get you 16 minus 1, which is 15. Does that make sense? And then you'd get 15/8. Okay, no problem. All right, so for this one, the reason why it's unique is the fact that you're sitting there, you're thinking, okay, well, Mrs. Kim said, let u be equal to something that if I take its derivative, I see the baby function somewhere, and this doesn't happen here. Okay, so in this event, what you'll notice is that you have two linear terms inside, well, a linear term inside the square root function right here, and then a linear term on the outside. So this is the only way you would kind of spot this. And then the other method of integration will eventually learn integration by parts. You couldn't possibly do it with integration by parts. So yes, someone suggested, well, the only baby here could be 2x minus 1. So let's go with that. Okay, so we're going to let u be equal to 2x minus 1. When we take its derivative, we get du equals 2 times dx. And so here becomes where, let's say you're going to go and you're like, okay, well, I don't have anything for x for now. I have 2x minus 1 is u, so that's square root of u, that's fine. I can solve for dx. Dx is equal to du over 2, so I have du over 2. So let's work some algebra magic here. I have that the 2, when I solve for dx, you know, what typically happens is like at this stage right here, the x would cancel out. But we see here that it doesn't cancel out. So we have to somehow manipulate this integrand so that it's just all u. So the goal is, how am I going to do this so that it's all u? Do I have someone brave enough to volunteer a suggestion? How do you guys think you can trick this problem so that it's all in terms of u and not just x, or not have and get rid of this x somehow? Excellent, you guys. So that is correct. You have u in terms of x. So simply solving for x in your equation, good. So u plus 1 equals 2x, divide through by 2, and you get x is equal to u plus 1 over 2. So let me highlight this part. So I'm going to take x and replace that with u plus 1 over 2. So it becomes the integral of u plus 1 over 2 times the square root of u times du over 2. In the chat, you guys, can you type out what constant can you guys pull out to the front? What constant can you guys pull out to the front so that it's just not so messy looking here? Okay, so you can pull out the over 2 and the over 2 and make that 1/4 out front. Then what you guys really have is u plus 1 times the square root of u, or u to the 1/2. If some of you guys look back at your integration, basic integration quiz, and you made a mistake here, it might have been that you forgot exponent rules, right? That's u to the 2 over 2. So when you're timesing, you're adding the exponents. So that's u to the 3/2 plus u to the 1/2 du. And keep in mind, sometimes students will do that and go, oh, I'm done. I already took the antiderivative. We haven't taken the antiderivative, right? So now when you guys add 2 over 2 to 3/2, you get u to the 5/2 times the reciprocal, so 2/5, plus u to the 1/2. If you add 2 over 2 to that, you guys get u to the 3/2 times 2/3 And then remember that everything out front has the 1/4, and then we still have a plus c at the end. Okay, and then lastly, are you guys done? I see students all the time leave their answer like this. What's wrong with my answer? What did I forget to do, you guys? What should be your last step? Yeah, it's not in terms of x, right? So the initial question is that it has to be in terms of x. You guys can leave the 1/4 out. U is equal to 2x minus 1 to the 5/2 plus 2/3, 2x minus 1 to the 3/2, and then plus c. So all of that is my answer. You don't have to, but you could distribute 1/4. That's considered algebraic. So I think if you were to distribute the 1/4, it would be fine. I would say that on a multiple choice question, it probably would be distributed and simplified. Is there any steps that you guys have questions over for? And just to recap, I know we're at the end of the class right here. Is that at this point right here is where we replace x with what we solved for u. We pulled out the 1/4 so that it's out here, and then rewrote this so that it's u plus 1 in parentheses, distributed that out to get u to the 3/2 plus u to the 1/2. The antiderivative of u to the 3/2 is u to the 5/2, and then don't forget to multiply by the reciprocal. Same thing with 1/2, add 1, and you get 3/2 times by the reciprocal. And then last step is just make sure you replace your u's with the x. So in the chat, can you guys type